Motions of the Earth. When we look out from a moving train, we find that all objects, trees, houses, fields, pillars, seem to move past us while we are stationary. But actually, it is we, inside the train, who are moving, not the objects outside. Similarly, the Earth, and along with it, everything on it, including us, is in motion. The Earth may seem to be still beneath our feet, but it is actually moving. It is spinning around its own axis, as well as circling around the Sun along an elliptical orbit. These two motions of the Earth are known as rotation and revolution, respectively. Rotation. The daily spinning movement of the Earth from west to east on its own axis is termed as rotation. The imaginary line, axis of the Earth, is tilted at an angle of 23.5 degrees to the vertical plane. It makes an angle of 66.5 degrees to the orbit or path of Earth's revolution around the Sun, known as orbital plane. This tilt of the Earth is fixed even when it revolves. This is called the rotation of the Earth's axis. The tip of the axis is called the North Pole. The northern point is called South Pole. Effects of rotation. If you wake up early in the morning, you will notice the darkness of the night gradually fades away with the break of the dawn. Gradually, the sun rises in the east and lights up the Earth from the entire day. In the evening, the sun sets in the west and night comes after dusk. In truth, however, it is the Earth that changes its position and not the sun. This important phenomenon of day and night is an shape of the Earth and rotation on its axis. The portion of the Earth that faces receives the sun's rays and experiences the day, while the half, which is on the other side, away from the sun, experiences darkness or night. The imaginary line that separates the lighted portion of the Earth, day, from the dark one, night, is termed as the circle of illumination. In between day and night is a period of diffused light termed as dawn and dusk or twilight. When the sun has not yet appeared on the horizon, but there is faint light in the surroundings at daybreak, it is termed as dawn. The sun's rays are slanting at this time. Noon is the period of maximum heat as the sun rays are vertical at this time of the day. After the sun sets in the evening, there is a period of faint light before total darkness of night. This is termed as twilight or dusk. As the Earth rotates from west to east, the sun, the moon, and the stars seem to move from east to west. The concept of sunrise and sunset also gives us a sense of direction based on the position of sun as viewed from Earth. The sun rays are vertical at noon and slanting in the morning and evening. You can understand this by observing your shadow during the daytime. Revolution. The annual movement of the Earth around the Sun along a fixed path is called revolution. The fixed elliptical path along which the Earth revolves is called its orbit. The Earth revolves along its orbit at a speed of 29.6 km per second. It takes 365 days, 5 hours, 48 minutes, 46 seconds, approximately 365 1/4 days to complete one revolution. For the sake of convenience, 365 days is taken as a single year. The extra quarter of a day adds up to make a whole day in a period of 4 years. Thus, we have a year with 366 days every 4 years. It is termed as a leap year. February 29 is the additional day added to compensate the difference of the common year, 365 1/4. The year 2016 was a leap year. Can you say which was the first leap year of this century? When will you again have a leap year? Effects of revolution. The revolution of the Earth along with its inclined axis determines the primary distribution of the Sun's energy throughout the Earth. Its primary effect is the occurrence of different seasons throughout the Earth. The varying lengths of day and night throughout the Earth are a result of this. Phenomenon of seasons. The entire year is divided into 4 seasons: spring, summer, autumn, and winter. It is based on the tilt of the Earth's axis and revolution, which positions the places nearer or farther from the Sun. It determines the intensity of Sun's energy received by that place at a particular time of year, and hence warm or cold weather. The given figure shows the position of the Earth in its annual journey around the Sun. The main reason why we experience seasons is because the Earth's rotational axis is not perpendicular to the orbital plane. Because of the axial tilt, the angle of the Sun's rays hitting a point on the Earth's surface changes with time in a year. Equinox. On 21st March and 23rd September, the Sun shines vertically overhead on the equator at midday. Position 1 and 3 in given figure. The day and night are of equal duration throughout the world. These 2 days are termed as equinoxes, meaning equal nights. 21st March is termed as the spring or vernal equinox. The northern hemisphere experiences spring at this time, while the southern hemisphere experiences autumn. On 23rd September, termed as autumn equinox, the northern hemisphere experiences autumn, while the southern hemisphere experiences spring. It is neither very hot nor very cold in any hemisphere. Solstice. A solstice is the day when the midday sun shines vertically overhead at one of the tropics, that is, Tropic of Cancer and Tropic of Capricorn, and the duration of the day is the longest in that hemisphere. 2 solstices are summer solstice, position 2, and winter solstice, position 4. On 21st of June The Tropic of Cancer, 23.5 degrees north, receives the direct rays of the sun. The northern hemisphere receives maximum warmth and sunlight and experiences summer season. Days are longer than nights during this period. Places in the northern hemisphere experiences longest day and shortest night on 21st June, summer solstice. The North Pole is tilted towards the sun, and places beyond the Arctic Circle experience daylight for 24 hours for 6 months at the North Pole. Conditions are reversed in the Southern Hemisphere, which experiences winter during this period. On 22nd December, the Tropic of Capricorn, 23.5 degrees south, receives the direct rays of the sun. The Southern Hemisphere experiences summer with longer days and shorter nights. The South Pole is tilted towards the sun. Places beyond Antarctic Circle have continuous daylight for 24 hours on this day, while places beyond Arctic Circle in the Northern Hemisphere have 24 hours darkness on this day. The South Pole receives 6 months of daylight during this period, while the North Pole has continuous darkness for 6 months. This day is termed as winter solstice, with the Northern Hemisphere experiencing winter.